Today's lesson, we're going to use what we learned in the first two lessons. We had a lesson about squares and square rooting, and we had a lesson about classifying triangles and some things about triangles. Today we're going to be using that in the Pythagorean's theorem. The Pythagorean's theorem is an equation that we can use to figure out the missing side of a right triangle. This only works for right triangles. So if you remember, a right triangle is a triangle that has one 90-degree angle. Now, you have to know two important words. One of those words is leg, and one of those words is the hypotenuse. When you find the right angle, which is right here, the two sides of the triangle that come off of that are called the legs. Okay? One of those legs we're going to label with A, and one of them we're going to label with B. And it doesn't matter which is which. One of them's A, one of them's B. Here's the right angle. The line across from it, which you might call the diagonal, it's a diagonal, is called the hypotenuse. And this is going to be the C. So we have an A and a B and a C. And the equation that we can use to find the missing side of any side here on this right triangle is going to be a squared plus b squared equals c squared. If you take the length of side A and you square it, and you take the length of side B and you square it, it equals the square of the third side. So let's see how that works. In this triangle, we recognize first that it is a right triangle because it has a right angle in here. So these would have to be the legs. 15 and 20 would have to be the legs. One of them is going to be A, one of them is going to be B, and we're going to be looking for the hypotenuse, which is C. So we're just going to plug these numbers into the equation. So when we do that, you will notice it doesn't matter whether 15 is here or here, it's going to have the same answer. We have 15 squared plus 20 squared, and that's going to equal c squared. Now to evaluate it, we have to square both the numbers 15 and 20. 15 squared is 225. 20 squared is 400. That equals c squared. We add the two together. That is 625 equals c squared, but we're not finished yet because we want to know what side c is, not c squared. And we learned that the opposite of squaring is taking the square root. So at this point, to solve both sides now, you're going to take the square root of both sides. When you take the square root of something squared, that just leaves it with c. So basically, to solve for c squared, you just have to take the square root of 625. And that is going to be 25. So we know the missing length over here is 25, and we don't know the units. So 25 units. Same thing on this triangle. First, we notice that it is a right triangle. We see the two legs, so we know this is A and B, and we're looking for C. So it's the same as the last one, so we plug in the numbers. 8 squared plus 15 squared equals C squared. So we square both of those numbers. That would be 64 plus 225. We add them together for 289, and now we just take the square root of 289, and we find that it is 17. The missing side here is 17 units. Now, the nice thing about the Pythagorean's theorem is that you can find any of the missing sides. You can find the hypotenuse, which was C, or you can find one of the legs. It works the same way. On this right triangle, you'll notice here's the right angle. Here are the legs. This time we're looking for either A or B. So I'm just going to call A 6. B is unknown, and C is equal to 10. So this time when we plug in the numbers, we're going to plug in 6 to either A or B. I plugged it into A, but this time we know the hypotenuse, or the C. So we write 6 squared plus B squared equals 10 squared. Okay, so now we square both the 6 and the 10, and you would have 36 plus b squared equals 100. Now, here's where we go back to solving for a variable. We want to get this variable by itself, so we're going to kick the 36 over to the other side. So we're going to subtract 36 from both sides. This is solving a one-step equation. Okay, when you kick him over to the other side and you subtract from 36 from both sides, You're going to have b squared is equal to 64, but we're not finished yet because we don't want to know what b squared is. We want to know what b is. So we take the square root of both b squared and 64, and we find out that the missing side is 8 units. So you can use this Pythagorean theorem to find any side of a right triangle. Here's one just like that. This time again, we're looking for one of the legs. So when we plug in the numbers, I plugged in 16 for A. I'm looking for B, and the hypotenuse, or C, was 29. Now I have to square 16 squared and 29 squared. Probably want to use a calculator for that. We have 256 plus b squared equals 841. Again, we want to get the b squared by itself on one side of the equation. So we're going to subtract 256 on both sides. We kick him to the other side and he changes signs. That leaves us with b squared is 585. And when we take the square root, this time it's going to be a decimal, and we're just going to round to the nearest tenth. So let's look at an example of this in the real world. A volleyball court is 30 feet wide and 60 feet long. A player is serving a ball from one corner, here's the person, serving the ball to the other corner. How far is this? Well, if you look here and you have a rectangle and you want to know the distance from one corner of the rectangle to the other, we have created a triangle with two legs. So here's our legs, A and B, and we're looking for the hypotenuse. So when we plug in those numbers, we would have 30 squared plus 60 squared equals c squared. We square both of those numbers, 900 plus 3,600, add them together, take the square root, and it would be approximately 67 and 1/10 feet. Again, you're just using the Pythagorean theorem to find a missing side. A 15-foot ladder leads up the side of a building. So we have a 15-foot ladder. Ladders lean. So here would be your 15-foot ladder. You know the hypotenuse. The foot of the ladder is 5 feet from the base of the building. So they're saying the distance from here to here is 5 feet. Now you know one of the legs. How high up the wall, so what we're looking for is this height right here, which is just one leg of the right triangle. So we would just set up our equation. There's my 15, there's my 5. I'm looking for my x. So I plug in my numbers, and I put x squared. It can be a squared. Doesn't matter what the variable is. We're going to square 5 and 15, and we're going to get x squared equals 25. X squared plus 25 equals 225. Now we have to subtract 25 on both sides to get x squared by itself. X squared is 200, but we're not finished until we take the square root and we round it to the nearest 10. So use this, and good luck on your assignment.